Let's now try to trace our recursive algorithm or a recursive implementation of the binary search in Java. I'm going to look at maybe two possible inputs over here. So in one case, we're going to search for 18 in this particular array, in which case it does exist. You can see it's over here, but not exactly in the middle just yet. So we do have to recur for a couple of times. We'll see. And for the second input, it's the value 7. Which does not exist in this particular array over here, right? By the way, for the purple numbers over here, these are just the indices. So for our convenience of tracing, I'm putting the indices as well. Let's now do this one first. And let's now start with the search over here. So we're going to call the search, and we got array over A, over here A, call by value, and also search for the value 18. So that's the key, right? You can think about the 18 over here is the key that we're searching for. And by definition, we're going to invoke the recursive helper method over here, and then we're going to call by value, pass the same reference A, and this will be very important to see. In the very beginning, the entire range of the array indices will be the search space, right? So that means in the beginning, it will go from 0 to 8 over here. So this is the initial search space. I don't really have the space to actually put the code side by side, but you can definitely go back to the source code over here, which we went through line by line earlier, right? But if anything that's needed, I'll definitely cross-reference for you. All right, let's now go on. And over here, we're going to actually, in this case, if this is the entire search space, we need to calculate the middle value, right? So the middle value is going to be accessed by the middle index over here, which will be from plus 2 divided by 2, right? So in this case, I'll just say m for short. The middle index is going to be equal to from plus 2 divided by 2, which will be 4. So that means we're looking for the middle index 4. In that case, the middle value over here is going to be 8 at index 4, which will be exactly equal to 15. So this will be the value to be compared against the key value 18, right? So you can see the key 18 is strictly larger than 15, right? It's really important to see that. You can see the key 18 over here is actually larger than the value of 15 that we actually compare, right? So you can think about this is 15 and over here. So that means where should we actually recur on? What should be the narrow search space? We got two options over here. Should we go on the left, where all the values over here are strictly less than 15? Or should we go to the right, in which case all the values are strictly larger than 15? Apparently, since the key is larger than 15, so it should really exist over here if it does. All right, so that's why we have to actually recur right now. So that's why you will see the another recursive call to the binary search helper. In that case, we got this value over here. Can you see why it should be 5 and 8 over here, right? You can see here, the 5 over here is exactly the middle plus 1, right? You can see this one here is exactly the middle plus 1. The middle plus 1. And this 8 over here is exactly the same as the 2 over here as before. That one doesn't change. So this corresponds to the middle plus 1 and the 2 over here, right? Just want to draw the correspondence for you. Right, middle plus 1, and this will just be the 2 value, right? So that means the narrow space now becomes from 5 to 8. So this will be from 5 to 8. Let me just try to draw that over here, from 5 to 8. So this is the search space of the first recursion. Search space of the first recursion. All right, so far so good. And for this particular search space, before we can recur again, we want to calculate what the middle index is. All right, so let's now calculate the middle index over here. So for this one here, you can see the from is 5 to is 8. From 5 to 8, what's the middle index? So the middle index is going to be the same formula, 5 plus 8 divided by 2. So 13 divided by 2, get an integer quotient, that'll be 6, right? And also, what will be the middle value accordingly? The middle value will be at index 6 over here, so that will be 21. So that's the value we're talking about over here, right? The middle value is going to be 8 at index 6, which will be 21 over here. And we want to now compare this particular value over here against the same key over here, right? Earlier, we knew that 18 is larger than the middle value, 15. So that's why we should really go to the right. And right now, 18 is actually less than the 21. Agree? In that case, we should really go to the other end, right? So that's really the less than over here. Less than the middle value, 21 over here. So that means we should really recur on a different place, right? We should really recur on over here, right? So this is the final recursion we may need. But I want to show you the correspondence. So that means we are going for this case. That will be from and middle minus 1. From will stay the same, which is simply just 5 over here. And the middle minus 1. You can think about the from over here and the middle minus 1, which would be just the same number. So that means we are actually looking at this particular spot. That's really the base case where the range of values is simply, the range of indices is simply just one index to look at. That's the base case, right? It's really important for you to know how you go from here, calculate the middle index and middle value, and knowing that the key is strictly less than the middle value, 21 over here, so you would know you have to recur between from and 2 minus 1. Sorry, from and middle minus 1, right? So let me just write it down over here. So you can think about this part over here is from, and the 5 over here is really the middle, which is 6 minus 1, right? So this will be the base case over here. And are we hitting the targets? Indeed, we are. You can see over here, 18 is really matching 18. So that means the element actually exists in the array. So eventually, we're going to return true in this case. So that'll be the ultimate answer. All right, so hopefully this detailed tracing over here really help you understand a little bit more, especially about how we set the narrow search space each time. The final thing I would like to also write down is you can think about the 5 and 5, really this part over here, right? I want to make it a little bit bigger over here. So this part over here, this box area, which is only one index over here, right? So this is the narrow search space. So this is the search space of the second recursion. Second recursion. Okay, let me summarize very quickly. This is the initial search space, which will correspond to this particular call, right? And this recursive call, the first one, narrows the search down into the half over here. And then the third recursive call is going to go for 5, 5, which narrows down the left half, right? So basically we go to the right and go to the left, and then we have hit the target. That's exactly what's happening. Of course, if you got a much larger array, you may have to go with this kind of a left, right decision every time. In that case, eventually you will get to the base case of size 1. Eventually, of course, if before you reach the base case, if the current middle value simply represents the key value you're looking for, in that case, you will just return. In that case, it will just be quicker for you to find the result. But the running time, as we'll see, will still be log n, the worst case. All right, so I think you got enough idea. I think it will be very important for you to try to trace this case over here to really see how the left and right and also how the indices for the front and 2 are being changed, right? I would suggest you do this exercise following what I did, right? So I already did my exercise, so I'm going to put a sticker over here. That's what I have just done. And for you, I would suggest you do the exercise your own, at your using your own time, right? This will be the exercise I would like to assign to you. Okay, let me just say exercise over here. Right, and I'm going to give you some sticker over here just to say it's actually going to be an exercise they're going to do. Right, so how about I put it here? Okay, work hard on this particular exercise, and then hopefully that will help you understand the binary search better. Let's now move on to talking about the running time for recursive algorithm, like a binary search.